Folks, welcome to my YouTube channel. Today we're going to look at the electrostatic question where we're given a net electric field. Here we have, it says, 2 point charges Q1 and Q2 are placed 1 meter apart. This is charge 1 and charge 2 are placed 1 meter apart. The magnitude of Q1 is 20 positive 20 nanocoulomb and is placed 0.6 meter. Do you see Q1 is placed 0.6 meter from point X as shown in the diagram below? And then if you look at Q2, we're not given the magnitude of that, is placed this meter from point X. But what do you need to understand? If the whole distance between Q1 and Q2 is 1 meter, and we are told Q1 from point X at 0.6, that simply means that this distance is the difference between 1 and 0.6, which is 0.4 meters, right? And the question now, it says, this is a point, guys, remember, this is just given, it's just a point. Now it says describe an electric field, right? An electric field, guys, is a region in space in which an electric charge experiences a force, right? You can repeat that. Now 7.2, it says if the net electric field at point X, it's 1300 to the right, determine the magnitude and sign of the charge Q, right? Okay, let's look at here. We are told that the electric field of Q2 on X and the electric field of Q1 on X, it's 1300, and in that direction is going to the right. But looking at charge 1, it's positively charged. Its electric fields are going to push the electric field direction of Q1 on X is going to go to the right. Now let's look at the possibilities of electric field of Q2 on X is going to which direction. If the net is 1300 to the right, and that simply means that this one is negative, this is negative, and it's going to there. It's negative. Do you know the negative? The field lines are to the right, so that means the electric field are towards. So the electric field that is exerted on Q is going to go to the right. So it's going to be that and that. That will amount to the bigger one, which is the 1300 that we were given, that is going to the right. And if you're looking here, the electric field of Q2 on X, it's going to be bigger than the electric field of Q1, right, of Q1, because of the distance there. The shorter the distance, the greater the electric field, that, right? Okay. Now calculating the magnitude of the charge there in 7.2, what we're going to do there, as I've mentioned, the direction. Okay, let's draw the free body diagram just to show you this. So the magnitude of the electric field exerted by Q1 on X, it's going to be that direction. This is the magnitude of Q1. Q1 on X, I'll say E1 because it's Q1. And then the magnitude of the electric field of Q2 on X, it's going to go to the right due to that, and it's going to be bigger due to the distance, right? So I'll say this is E2, right? And right, it will be like that. So in the vector diagram fashion, guys, it's going to be, this is E1, and then the E2, it's going to go to the right. Right? It's going to go to the right. It's going to be E2. E2. And then we have the net. The net, it starts from the tail of the first vector to the head of the last vector. Right? This is E net. The one that we're given, it's 1700. And another thing that you can get the direction of that electric field it's going where, if you can try to draw this, I hope it's going to work, without the direction of this one, it's going to tell you. Okay, we are told the E net, it's going to the right. Here's the E net. This is the E net. And then we are told that we are not told, in fact, but we know that the direction of the electric field of Q1 is going to go to the right due to its positive, and the field lines are going to the right, so it's going to be that. So this is E1. E1, which color did I use? Green. So it's going to go to that direction, and I'm gonna make it smaller because I see the distances there. It's a bigger distance and a smaller distance, right? Let me clean it. So this is E1. And then what will be the direction? If you can ask yourself, if you have that drawing and I want the electric field E2 of charge 2 on X, it's going to go in which direction in order to fulfill this? It can't go to the right. So the only possibility, it can't go to the left, sorry. So the only possibility, it will go that way. So it will be that way. So it will resemble this one. So it's E2, that. Okay, let's go to the calculation. That was not needed. I'm just showing you. And then the calculation now, it says we wanted the charge. So what we do now, we say E net is equal to E1 plus E2. They're going in the same direction to the right, so it's going to be positive there. So then it's going to be KQ1 divided by R squared plus KQ2 divided by R squared. So it's going to be, we're substituting now, and we were told the E net is 1300 to the right, so it's going to be positive. You don't have to put the positive there. And then we put the Q there, and the Q1, it's 20 nanocoulomb. And then we divide by the distance. It was distance from here, it's 0.6 Q1 to X, it's 0.6. So distance at 0.6 square plus, we're going to electric field 2, we put the K there, this K, and then we want Q2, and the distance there, as I've mentioned, it's 0.4 square, this distance here. And then the math now behind all this. So if you calculate this, if you punch this in the calculator, it's going to be what? 500. And then you have 1300 there. And then that in the calculator plus this in the calculator, it has to be let me punch it quickly. So it has to be my calculator, 9 times 10 to the power 9 divided by 0.4 square. It's going to be 5. Guys, remember what I'm doing here. I'm punching this in the calculator. So it's going to be 5,625 times 10 to the power 10 what? Q2. And then I transpose this. So it's going to be Q2 is equal to 1300 minus 500 we're going to divide by that. 5,625 times 10 to the power 10, and then Q2, it's going to be the answer there. It's going to, when you punch that in the calculator, it's 1,42 times 10 to the power negative 8 coulombs. And we were asked that to say this charge, what is this charge? This charge is going to be, even though the answer it's not negative as I mentioned earlier, so it's negative, right? It's negative 1,42 times 10 to the power, or I can just say negative. Yeah, it's negatively charged. Right, let's go to the next question. It says Q1 is removed. Now draw an electric field pattern of Q2. I'm not good in drawing. This is 7.3. I'm not good in drawing. This one is removed. Now you are only left with this one. Basically, they said draw an electric field pattern of Q2 only. So here's a charge and it's negative. And we know the negative, the electric field lines are going towards. Guys, make sure your lines are perpendicular to that surface and they touch it, and none of enters the center, guys. None of enters the center, the arrows. It has to be like that. Yeah, like that. It has to touch, guys, there. This has to touch. Yeah, like that. Check the textbook. How is it drawn, guys? Now in 7.4 it says calculate the magnitude of net electrostatic force, or that an electron would experience if it's placed in X. Now guys, the electron it's placed here, right? So they wanted the net electrostatic force that is experienced by that electron. So now one thing that you need to remember, this one is positively charged and this one is negative. This is going to attract. So this is going to experience an electrostatic force in that direction. So the electrostatic force of one is going to go in that direction, and this is negative, and negative and negative, and this is going to repel this one. So the electrostatic force of again, the electrostatic force experienced by this electron will go in that direction. So this is F2, but of course this one is going to be bigger. Okay, let me do this. Let me do this so that I can make sense. So this is the electron. The electrostatic force that is due to this one, to X, is going to, oh come on. So this will experience an electrostatic force in that direction. From where? From Q1. And then from Q2, this one will repel this one in that direction. It has to be bigger. So this is what? F2. And this one will attract this one. That's why they're both. So the net electrostatic force is going to go to the right. Now 7.4, which formula are we going to use? The E is equal to F over Q. Why are we using that one? Because we have the electric field, they want the net electric field, and we have the charge of the electron. So in other words, this is the net that they want. We have E net, and we can find the F net in that formula. We have that. So let's substitute. So the net electric field there, it's 1,300, and the F net is the one that we want, and the charge there, it's 1.6 times 10 to the power negative 19. And if you punch that in the calculator, it will be the F net. If you cross multiply there, it will be 208 times 10 to 0.8, whatever, guys. That's the one I've written there. Newtons. And the direction as I've mentioned, it's going to be left. Right, it's going to the left, the net there. I hope that guys makes sense. Please don't forget to subscribe on my channel and like and watch my video till the end and share with your friends and families. Cheers, bye.